Hello. Welcome to this evening's TI Technology webinar hosted by Texas Instruments, where tonight we'll take a look at how TI Technology can help your students prepare for the Grade 8 and Algebra 1 STAAR assessments. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm very happy to introduce our two panelists tonight, Blake Helm and Kathy Hale. Blake Helm is a facilitator of mathematics with Tyler Independent School District and also a research fellow at Stephen F. Austin University. He holds a master's in school mathematics teaching from Stephen F. Austin University. Now in his 12th year as an educator, Blake has also taught elementary and middle school. Thanks for being here. Hi, everyone.
Good to be here.
And Kathy has been a T-Cubed regional instructor for many years, and after working in Texas middle and high schools, she transitioned to working at a regional education service center. She provides professional development opportunities and tech support for teachers in 13 Texas counties. Much of her work has been developing materials and strategies to help students utilize graphing technology to improve their performance on state assessments. Thanks for joining us, Kathy.
Hello, everybody. Hope you find this to be a beneficial hour with us.
We are expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. Once we move to the software, the right section of your screen will be replaced with a floating toolbar. You can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, at the end we'll be providing a link to the events, certificate of attendance. Once the recording is available, if you'd like to follow along with your handheld or your software, and we really hope you will, we recommend doing this with the recording. That way you can download any activities and then pause and rewind the recording as necessary. We don't expect to have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Kathy is going to discuss our agenda.
We're going to be looking at a few things tonight to kind of give an overview of how you use TI technology to help your students perform at their highest possible level on our state assessments. Blake is going to be looking at a quick overview of the TEA documents that are used to help us prepare, make sure that we have all the content in place. And then he and I will discuss some specific examples and give you some strategies that are available. I'll be using the TI-84, and Blake will be using the TI-Nspire technology to highlight some of the strengths that those two pieces of equipment have for our students to be able to perform well on the test. Also wanted to remind you that there are many free online resources on the TI website, education.ti.com. If you go into the activities exchange, for example, and just type STAAR in the keyword text box, it will pull out for you activities that are specifically written for students to prepare for their STAAR test. There will be some worksheets, for example, that are strategies that we'll discuss tonight, plus others that are student ready. There's also, for those of you who are Nspire users, a set of activities that have specific sample questions in TNS files where the students can answer those questions on their handheld.
Thanks, Kathy. And Blake is going to discuss our expected outcomes.
Thank you, Mike. Tonight, we hope to provide, as Kathy
mention some strategies to use with both the TI-84 and the Nspire technology, and looking specifically at some of the standards that are being assessed on the new 8th grade assessment, and pulling in some examples from previous Algebra 1 assessments, and really examining how the technology can be used in those test questions. And then also learning some techniques to help students effectively perform calculations, graph and analyze functions, and model and interpret univariate and bivariate statistical data. And then we will be also discussing how you can stay in touch with the upcoming things with TI through social media and some of the upcoming events.
Thanks, Blake. And it's all yours.
Thank you, Mike. So as Kathy mentioned, we're going to start off tonight by looking at a couple of documents from the state. And I'd like to draw your attention to this document right here. This is the STAAR Grade 8 blueprint for the state of Texas math STAAR test for this year. And I'd like to point something out in particular, and that has to do with reporting category 2. Things have changed a little bit, as most of us probably know, especially if you're a middle school teacher in mathematics in the state of Texas. We have brand new standards that are being assessed this year. If you're an Algebra 1 teacher, lucky you, you have one more year of the standards that you are used to teaching, and then you will have those new standards being taught and assessed next year. But wanted to bring something to your attention here within 8th grade. Within reporting category 2, as you can see here, we have 5 readiness standards and 9 supporting standards. And just as a reminder, the readiness standards comprise approximately 60 to 65% of the test. From just one reporting category, though, look at how many questions are addressed from this reporting category. Out of the 56 questions that will be on the 8th grade test, 22 of them will come from reporting category 2. And so tonight, we really kind of looked at this document along with the assessed curriculum document to kind of provide a focus in terms of the content that we will be looking at. As I mentioned before, we're looking at this really through the lens of 8th grade primarily, but the examples that we are pulling in actually came from the previous released Algebra 1 STAAR EOC test. And so there is still the application for Algebra 1 teachers as well. All right, so let's take a look at another document just to kind of highlight a few specific items. I've highlighted the standards that we will be addressing tonight. We're going to be looking at something with proportionality, and specifically 8.4C, 8.5E, 8.5G, and 8.5I. And you can see out of that set of standards right there, 1, 2, 3 of those are readiness standards, and then 8.5E is a supporting standard. And we're also going to see a couple of examples that deal with 8.9A, which is also a supporting standard. That's just to provide the context for the discussion and the content that we will be exploring tonight. All right, I'm going to turn things over to Kathy, and she's going to demonstrate some things with the TI-84.
And while we're transitioning, just a really quick reminder that whenever we switch presenters, that chat window which you may have opened or Q&A window you're just going to need to reopen. And again, you can do that by moving your mouse under that green floating toolbar. You can get those windows back open.
Hello, everybody. You'll notice that the first student expectation statement that I have on the document in front of us is actually out of the process standards, because I wanted to make sure that everybody remembers that using technology as appropriate is one of the requirements of our student expectations. And I do want to give you just a little bit of a philosophical statement about using graphing technologies for test preparation, which is a little bit different than how we would use the technology in our general instructional work. We need students to be able to use whichever format in order to be able to make connections. Excuse me, everybody in Texas has allergies. If you're here, you know what I mean. To be able to make sure that the students have flexibility in their approach to the question. We need to make sure that every student understands some things a little differently. When we do our classroom instruction, we have a tendency to spend a great deal of time talking about how different problem situations are different from each other. When I would suggest that you consider, when you're looking at working on helping the students use this as a tool for assessment, that we spend a little time discussing with the students how many questions are alike. That removes a lot of the intimidation factor. We're focusing, of course, on the algebra component tonight. We have to remember that algebra is all about patterns, and patterns only have three parts. We have a pattern, we have numbers that go into patterns, and we have numbers that come out of patterns. There's only a couple of different things that they can fundamentally ask the students to do. They're going to give them two of those parts and ask them what the third one is. And so when you look at your students' eyes and they're getting a little overwhelmed, when we start helping them cluster questions together and see that there's a lot of questions that look very different, but there's similar strategies that we can use in order to solve those. And my personal philosophy is always to have the fewest number of keystrokes possible. I want the students to understand what they're asking the machine to do, not to memorize a set of keystrokes that may only fit in one particular situation. This needs to be a broader discussion. I'm going to attempt now to give you an idea of what those would begin to look like. If you look at the problem that's on the screen, it's a fairly typical, straightforward question. This one, when it was actually on one of our STAAR tests, was a griddable question, and it said a student bought concert tickets online. The cost of the tickets in dollars of T tickets can be found using the function given below. We know our students oftentimes will have a function that's given to them. So I am on the y equals or equation editor screen on my handheld, and I'm going to type that. Especially with younger students, I have a tendency to ask them to type exactly what is written in front of them. Most of you would know that our students' mental energy sometimes isn't up to the task of a long test, and so I'm very particular about not wasting even the tiniest little snippet. I don't want a student to ponder, do I need to type the 0 or not? Just type the number in the problem. The machine can do that very well. So in this problem, we have $24.50 times the number of tickets that are being purchased, plus some sort of a $9.50 fee apparently at the beginning of the problem. So the question here is, what would the students be able to do then in order to answer the question? The students spent $83 on tickets. How many tickets did they buy? You can do this with graphing technology, but when we have a problem that is in our standard viewing window and we graph it, in many cases we do not see the information that we need. When we know that the students are taking a test that has a time limit on it, even though the tests are designed for an average student to finish in 2 hours and they give them 4, they still feel like there's a time limit. It's not efficient for testing purposes for them to spend a great deal of time changing the windows in order to find the answers. One of the things that I found works really well for students is to use the table function instead. You may or may not be familiar with that. It is the second function of the graph key, so I'll hit the second button and ask that key to perform its second function, which is to go to a table. The standard window in which the table will be viewed at the beginning when the students receive the test, for those of you that have not administered a test before with a handheld, they're basically put back to factory default, so the table will be set to input the value 0, use the pattern that we put in y sub 1, and calculate the values that are given. So in this case, all a student really has to do is to scroll down and look for the input value or the independent value for which $83 was the price. So they bought 3 tickets. Of course, we want the students to be able to work problems and solve them in a lot of different ways, but on the day of the test, we want them to use highly efficient strategies that are applicable to many, many, many questions. So that's one of the basic strategies. I've learned to love the table and some specialized capacities of the table that we will look at shortly, because tables don't lie. Windows can sometimes impact a graph so that students think they're seeing one thing, but tables are very clean, and it reduces mental and physical stress and fatigue, especially eye stress and fatigue. I want to go ahead and look at the next problem, which is dealing with verbal, numerical, tabular, and graphical representations. We had a pre-registration question that was sent in that was asking us to talk about strategies to help students read word problems, which is a very difficult thing to get students to do well. The calculators are not magic wands. I can't get it to actually read the problem, but there is something that is a very powerful way for us to help students use the machines well to answer questions that are, especially ones like this particular problem, that's pretty verbally intensive. If a student is working a problem by hand and they've done what they know to do or what they think is the right strategy to solve the problem, and they do not get an answer on a multiple choice that matches any of the answer choices given, they typically sort of throw up their hands, don't try again, maybe they'll guess something, but they don't attempt a question a second time. Whenever the students have confidence in their abilities to decipher problems, or they've tried something the first time and they don't get an answer, there's 2 things that happen. If they're doing it by hand, they don't know if the strategy was wrong or if they did a calculation that was wrong. When they're using the handheld devices, the calculations are removed from the process. So that tells the student that their strategy is flawed, and they are more likely, because the arithmetic is out of the way, to attempt a question a second time using a different strategy. So it can't exactly help us with the reading itself, but it can give the kids confidence to try a problem a second time if their first attempt doesn't work well. This, of course, is a very verbally intensive question. The approximate distance in miles between Los Angeles and a commercial jet flying from Boston to Los Angeles can be found by a given function. Where T is the number of hours the jet's been flying, which number of hours is closest to the amount of time that the jet has been flying if the jet is 1,500 miles from Los Angeles. Again, this question can be worked similarly, but requires a level of interpretation. Again, students can become really confident in this. I'm going to go back to my Y equals button and hit the clear key, which is in the 4th row last column, and type in the new function. One of the other things is students have to make a distinction between the subtraction key and the negative key. So this is a negative number, so we have to make sure that they type in negative 475. Students also become very comfortable that in this format, X is the variable we're going to use for everything, no matter what the problem says. Then I'm going to add to that 2,650. So again, I could look at the graph for this particular problem, but it's unlikely to give me very much information because these numbers are very, very large. So if I again go to second table, which is above the graph key, I need to know what I'm looking for. If I'm looking for an output that is 1,500 miles, then I can scroll down and say at 2 hours, the plane is 1,700 miles from Los Angeles, and at 3 hours, the plane is 1,225 miles from Los Angeles. My time has to be somewhere between 2 and 3 hours, so that the correct answer has to be F. Again, the table allows the students to look at the relationship of the values that are given in the problem. The machine does all of the arithmetic and the calculations for them, but they have to know the math to know what they're asking it to do. So this gives us an example of a very word-intensive question that's made very simple once the students understand I have a pattern, I have numbers that go into the pattern, I have numbers that go out of the pattern. My job is to type correctly. Machines are only machines. They'll give you the wrong answer if you put the wrong information in. And they will also sometimes have to interpret the answer. One of the other capacities that the machines have has turned out to be something that the students with which I've worked have absolutely fallen in love with. Again, this is a very straightforward problem. The students are given a set where they want to know which set of ordered pairs would come out of a pattern. So again, if I have a pattern, that's going to go in the equation editor under the y equals key. I have to clear out the problem from the last problem and type in the new pattern, which is 12 subtract 3x. In working with graphing calculators with my students, I've learned to say subtract when I mean subtract, and negative or minus when I mean a negative number, and it keeps them from hitting the wrong button. So that's just a presentation strategy working with students that seems to eliminate part of the issues. Now, I could go to the table, second table above graph, just as I've done before now, but I would have to scroll up and down and try to find -3 as an input value. For example, if I wanted to look at answer choice A and see if -27 was its dependent or output value. That's a lot of work to go hunting. This is where the fatigue factor really comes in for the students. So my students and I, as I've worked through this, have learned to go to second table set, which is above window. And this allows us to change the parameters of the way that the table operates. It's going to still begin at 0 in this particular problem and count by 1 unless I change the independent or dependent values. One of the strongest tools I've ever given my students that helps them keep a lot of problems very simple with the least amount of work possible is to go down to this row for the independent value, right arrow until the cursor is on the word ask, and hit enter. What this is now going to do is let the machine ask me, what values do you want to put in this pattern, so you can see what you're really looking for. Now if we go to second table above graph, it's empty because it's saying, hey, what X do you want me to use? So generally we know that if I try a single value, for example, if I input -3 in my checking letter A, if -27 doesn't come out, the whole deal's off, and that is not a possible right answer. I'm going to go to the next answer choice. -18 goes in. I'm looking to see if a 10 comes out. It does not, so B's not the possible right answer. If I try -5 going in, I'm looking to see if 27 comes out. The one thing that we have to be very careful to make sure the students understand completely using this strategy is that one wrong answer means the whole set doesn't work, but one right answer doesn't mean I'm sure I'm correct. The students would need to go ahead and input -1, check to make sure 15 comes out, input the 8, check to make sure -12 comes out. No student should ever miss a question like this because the machine does all the work. And you'll notice I only had to look at 5 numbers to check and make sure that this was absolutely the right answer. No question about it. And that's much less fatiguing than looking at the problems. I will tell you that one of the documents that Michael is going to share with you has screenshots of all of the things that I'm doing here. I just want you to think about the math right now, and you can go back and practice with those when you look at the recording at a later time. So again, you go to second table set and change, so the machine asks you what the independent or the input values are that you want to look at, so we don't have to look at numbers that don't apply to this problem. Your SAT analogy for today, window is to graph as table set is to table. Those are associated with the same key on the calculators on purpose, and that's a very powerful thing for us to remember. This keeps it clean. It allows us to only look at the numbers that apply to a pattern that we have. Since our assessments are multiple choice questions, that becomes a very, very powerful tool. Looking ahead at one of the other things, we know that the development of slope and the idea of having the students understand conceptually some things that are going on with equations is in a completely different place than it's been in the past. For those of you who are Texas Algebra 1 teachers, your students next year will come to you with a completely different background coming out of 8th grade this year than they had coming out of 8th grade last year. And so that's going to save you a great deal of instructional time. The conversation we're having with this problem is equally valid for Algebra 1 and the 8th grade end of course or 8th grade STAAR test. Joe's Movies charge $7 for a membership and $1 for each movie. The rental for the movie rental, Best Videos has no membership fee and charges $2.75%. We've got a graph here that shows the relationship of these. Again, this is a calculator screenshot. On the real test, it would have been a graph that did not have the labels at the top. The question is, determine the number of videos a customer would need to rent from each store for the cost to be the same. The new student expectation is to solve equations, systems of equations, graphically in 8th grade. So this one is a little bit more interesting because the students, like Blake said earlier, they have to know some math. The machine takes out the parts where they're the most careless. If they're going to charge $7 for a membership, again, I would ask the students to type the $7 exactly as it is. That's the beginning amount, and then it is $1 for every movie that's rented. And when I look at the graph of that equation, then the other scenario would go in y sub 2, where there is no fee to begin with, but just $2.75 per movie. The idea of rate of change, and if I don't do something about that, that's not going to work out very well. Remember earlier when I said that my first responsibility is to type? When I'm actually working with students, I ask them to pause at this point and look in the problem and look at the handheld and make sure what they've typed is what they intended. As I often tell them, it's only a machine. If you ask it the wrong question, it will give you the wrong answer. We know the graph in this case is not going to give us a particularly helpful set of information. Now, if this was a multiple choice question, I might have some values that I would want to put, but I don't have any numbers to ask the problem. So this is one where we would want to put the machine back on automatically giving us values to start with, and the same increment as always. The context of this problem is one movie at a time, so that's what delta table stands for. Now if I go to second table, again above graph, what I'm looking for is the place where the two y values are the same. So I just have to arrow down until I see it. and it happens pretty quickly. If I rent 4 movies from either company, it's going to cost me $11. And so there are times when the ask capacity works really well, and some other times when they have no numbers to ask, so they have to go back and figure out what the answer to the question is using more values. The one nice thing about the test writers, I don't know if any of you have been in the committee rooms with the test writers and with the TEA folks that actually put the test together. Most of the numbers are pretty reasonably close to that 0. So even if a student doesn't get a handle on ask, they don't have to look too far. But if the numbers were large, let's say we knew we were going to rent between 150 and 300 movies, we would want to be able to ask specific numbers. So again, let me review the things that we've talked about. Tables are very, very powerful. When you have multiple choice answers, putting the table on ask is cleaner and less fatiguing. When that's not available, sometimes the students have to go back and look at the values until they find the right answer. So I think that's the last example that I want to do today. So I'm going to make sure that Blake has some time now to show you some similar questions with the TI-Nspire.
Hey, Kathy, there you go.
I was having a little mouse issue again. Sorry.
All right. Everyone see that? Well, we're going to kind of continue with this idea of tables, except now we're going to look at it on the Nspire platform. This is a problem that was taken from the Algebra 1 EOC last year. And I pulled in this standard, 8.4C. The student is expected to use data from a table or graph to determine the rate of change or slope and y-intercept in mathematical and real-world problems. The question reads, which table shows the same rate of change of y with respect to x as y equals 4 subtract, that should read 5/8 x. Evidently it didn't pull my equation in, but that should read 4 minus 5/8 x. But we can look at that in a very similar way on the Nspire. And so that's what we're going to do now. The first thing that I'm going to do is I'm going to open up a graphs page, and I can do that by pressing the menu key. If you create a new document, which is what we have here, and you haven't created a page, the first thing you have to do is put some sort of page into the document. And we do that by pressing the menu key and then selecting the type of page that we want. And so I'm going to start off with a graphs page. And I think this is a good opportunity for us to discuss a couple of things with the Nspire in terms of the function editor that you see right here. As Kathy mentioned before, in one of the examples, she talked about the example with the, I believe it was with the cost, and it was like $24.50. I don't know. I think I've got that problem somewhere up here. And it was asking about the function. A lot of times we will see this referred to as a function on the state test. And so, we could have a debate about the notation. whether it's in equation notation or function notation. And we're going to kind of explore that just a little bit in terms of the Nspire. I'm going to go ahead and use the function notation for now. And the reason being is because we have some extra things that we can do with functions on a graph that we can't necessarily do with an equation. One of those is generating a table from that relationship. And so I'm going to put this function in just as it reads over here. And this is going to be 4 subtract. And I'm going to pull up my template for a fraction. And this will be 5/8 and then x. And type or just press enter. Now, I can do a couple of things here. I could begin to look at these values on the line itself, but let's go ahead and generate our table. To generate the table on the Nspire, once we have the graph of a function, we press Control-T, and that will pull up our table. It will actually split the screen. We can see the function on the graph of the function on the left side, and then we've got the table of values on the right. Okay, for this question, the students are being asked which table has the same rate of change of y with respect to x as this function, 4 minus 5/8 x. Whenever I looked at this problem, my mind went to, well, I've got some tables here. Wouldn't it be nice if we had the table of values for this function? And wouldn't it be really nice if we can go and use that similar type process that Kathy did where we can ask or get the handheld to ask us what value do you want to look up, and it will generate the corresponding value for that function. Well, we can do that. Right now, my table is the part of my page that's activated. So if I press Menu and arrow down to Table and go to Edit Table Settings, I can tell the Nspire where I want the table to start, what my steps that I want to use will be. But I can also tell it whether or not I want it to generate values automatically, or if I want to have it ask. And so, oops, let's try that again. And so in this case, I'm going to have it ask me what independent values I want to work with. Okay, once I switch that, select OK. Now I can begin putting these values in. So let's start with this first one over here that is answer choice A. Let's see what happens when I put a -3 in place of x. That doesn't match what I have in this table, so I already know that A is not the right answer. Let's try answer choice B. Let's start with -4. Press enter. I know that in this function, the value of the function when x is -4 has to be 6.5. Therefore, B cannot be the answer. But it does, I do see that value of the function in this table, answer choice C. So let's go ahead and try some of the other values of x. Okay? If x is 2, that matches. What if x is 4? That corresponds with this table again. So let's check and see what if x is 8. And that matches as well. I have a pretty good idea that this is probably my answer choice. When I was in the classroom, however, I used to always emphasize to my students, it's a good idea if you're not entirely sure to check all of your answers. So let's take a look really quickly and just try this -3 that we see as the first entry for x in answer choice D. Again, we had that at the top of our list. So we technically didn't have to put that in. But that one doesn't match the function value for x in answer choice D. So we know that C has to be our correct answer choice for this question. Now, one of the things that I thought about that we might need to discuss with students with this type of an approach is the Nspire does have the ability to graph an equation. I'm going to undo some things. In fact, let me just undo some things here. Nope. There we go. We can graph this function as an equation in the form of y equals. But as I mentioned before, and I think for time's sake, I won't demonstrate that because there are some other things that I do feel are more important. But essentially, when you graph things using the equation template instead of a function, you don't have the ability to generate the table. And so if you're working with kids on the Nspires, it's really good to get them into the habit of using the function editor and graphing functions whenever they possibly can. Obviously, there are times when we're not working with a function and we have to graph an equation. But for the purposes, especially in 8th grade math in the state of Texas, everything is really generated to push towards this development of the idea of a function. And so we can really capitalize on the function features in the function editor. All right, let's look now at another problem. And this one is similar to the last example that Cassie demonstrated with the system of equations. And I am going to approach this two ways. I'm going to approach this first using a graphical method because the standard actually talks about using graphs to find these solutions. And let's go ahead and add another page to my document. And I'm going to add a graphs page. And in this case, I am going to use the equation template because I can put these equations in using the same form that I see right here. To access the equation template, in my function editor, if I do a control menu, it pulls up the menu for me to select what it is that I want to graph. And so in this case, I do want to graph an equation, and I want to graph a line, and it's going to be in the form of AX plus BY equals C. Now things look really different here compared to the way they do whenever I'm graphing something in function notation. And once again, I want to stress, as Kathy did, it's really important to train your students to input things as they see them, as much as they possibly can. We'll see an example in just a few minutes where we may have to make adjustments before we input it. But in this case, I can simply type in the numbers 15x. However, because this is a standardized form of the equation, in order to be able to work with this part right here where I'm subtracting the 12y, the students will have to actually put this in as a negative 12 and then use the arrow key to move over to that last box and set it equal to 13. Okay, we're going to go ahead and graph that one. And now I'm going to press Control G to access my function editor, which now is holding this equation template for me. And I'm going to graph the second equation there. Okay. Now, as I mentioned, I wanted to demonstrate how to solve this graphically first, and then we'll take a look at another option that we have. I've got these two equations on my graph screen. If I press menu, though, I have some additional options that I can access. And in the geometry menu, under points and lines, I can graph an intersection point for objects on the screen. And so I'm using my cursor on my computer, but on the handhelds, you just use the trackpad to select the two different lines that we want to find the intersection for which we want to find the intersection point. Now the question was asking, what is the value of x in the solution to the system of equations below? Well, right here, the coordinates for this intersection point are 0.333, and actually the calculator is, or the handheld is it's rounding that decimal as it is right here. This is another opportunity for us to have a little bit of a discussion about how the technology is helpful, but we still need to have, and our students still need to have that number sense. They still need to know some basic things, such as the decimal equivalent, or the decimal approximation, in this case, for 1/3. And so by looking at this, hopefully our students would realize, well, this is in fraction form. All of my answer choices are in fraction form. And hopefully they would realize that 0.3333 is approximately 1/3. Now, let's look at a little bit different way of solving this problem. I'm going to add one more page, and this time I'm going to add a calculator page. Nspire has some tools within calculator pages that will be pretty powerful for our students. What I want to demonstrate right now is the use of the linear solve. And so we access that by pressing Menu, selecting Algebra, and we're going to select Solve System of Linear Equations. In this case, we are dealing with two equations. The variables are x and y. So everything is set up here the way it should be. We're going to press OK. Once again, we want to train our students to input things exactly as they see them. So I'm just going to type in 15x minus 12y equals 13. And then I'm going to use my arrow to input the bottom equation. 30x plus 9y equals 4. Once I have the equations set up and completely entered, I just press enter. In this case, it is displaying it in fractional form. 1/3 is my x value, and -2/3 is the y value for the solution for this set of linear equations.
Hey, Blake.
Yes.
We had a really great question from Renee. She wants to know if students are allowed to use that feature on state exams in Texas.
That is an excellent question, and the answer to that is yes, they are.
I'm going to interrupt you for just a second. One of the documents that will be in your folder from Michael are the instructions of how to have the calculators set for the exams to be legal in Texas. There's a specific document called Texas Press to Test. We get to access all of the functionality of the Nspire. We do not have to deactivate anything in the Press to Test mode. And so those documents with complete instructions will be in your folder and in the emails that are sent to you at a later time.
Good question. Excellent question. Mike, do we have time for one more, or do we need to take a few minutes to kind of
let's do one. Let's do one more.
Okay. So I do have one more I wanted to at least briefly discuss and model. And this is kind of like the problem that Kathy talked about earlier, in that there's a lot of words in this problem, and so again, I want to emphasize too the importance that even though we have the capability to do things with the arithmetic with the machine, such as what you've just seen here with the linear system, solving the system of linear equations using the LinSolve. And likewise with what we'll see with this problem using the Nsolve on a calculator page. Our students still have to be able to think mathematically, and they still have to be able to take things such as this problem that is basically a description with a lot of words, and be able to represent that in a formal mathematical way. I'm going to start off by adding one more page, and I'm going to go back to the graphs page for this. I'm going to leave this in the function format for this problem. In this particular problem right here, the information in the problem says that the volume of the mass of a substance varies directly with the volume of the substance, and that the volume of 100 kilograms of the substance is 80 liters. What is the volume in liters of 3.2 kilograms of this substance? If we go back to our calculator page, I'm gonna set something up on the calculator page and then use that to talk about how we can help students think about this in terms of the graph, and then I'll come back to the feature here. I'm going to go ahead and set this up using the numerical solve under the Algebra menu. And basically, this is going to give me a template to set up the proportion to be able to talk about how students can think about this and how they can translate the representation in a proportion format to something that we can put in the function editor. All right, so in this problem, it tells me that the volume of 100 kilograms, I'm going to go ahead and set this up as 100 kilograms in my numerator here, is the volume of 100 kilograms of a substance is 80 liters. So I'm going to put 80 in my denominator here, and I'm just setting up basic proportion with this. Okay, I'm going to use my template tool again, set up the other part of this proportion, and that we're wanting to know how much volume is there in 3.2 kilograms of a substance. Okay, now I'm going to leave this right now. There's one more thing that we actually have to do to actually have the handheld calculate this for us using the install. But I'm just going to leave this like this for just a second. One of the things that our students really need to know when we're talking about direct variation is when we're setting up this, if we're using the idea of cross products, whatever is going to be multiplied by this variable here, so in this case, if we were to use cross products, 100 times x would be equivalent to whatever 80 times 3.2 is. Well, that is going to come in really handy when I go to my function editor. Because if I understand that, this times this is equal to whatever this times this is, then I really already have everything I need to be able to set up a function to represent this relationship. All right, so let's do that. And in this case, the function is just going to be 100x. And let's go ahead and graph it. Now, that's not what the question was asking us, but it's going to set things up so that we can do something graphically to solve this. Once I have this function here, I can go to Menu and go down to Geometry again, go to Points and Lines, and this time I'm just going to put a point on the graph. And I'm going to put this point right there. Okay. I'm going to press the escape key to let go of the point, so to speak. Now, in my proportion here, 100 times x is going to be equivalent to 80 times 3.2. Well, 80 times 3.2 is 256. Okay? So if I access this coordinate here, I can actually change the value of the y coordinate here. And we're going to switch this and just input 256 and press enter. Now, where did that point go? Well, it went somewhere on this line. And if we want to see that, we can press Menu, go down to Zoom, and zoom to fit. Press enter. Now we can see this point on the graph. And I know from this coordinate, from these coordinates here, when y is equal to 256, x is equal to 2.56, or 2 and 5600. Let's take a look at that now on the calculator page. As I mentioned before, I'm using the nsolve capability, or the nsolve feature, but I have to do one more thing, and I have to tell it what is it that I'm wanting to solve for in this proportion. Well, I want to solve for x, and I do that by pressing the comma and then the variable for which I want to solve, and press enter. And as you can see, x is equal to 2.56, and that's also what we had represented on the graph here. Any questions?
Like, we're actually a little bit over on time, so if it's okay, I'd like to sort of end things where we're at, and then if anyone does have any questions, follow-up questions, I can give you some information as to where we can go to get those questions answered.
Okay, sounds good.